Hello students, today our question is, for a radioactive material, its activity is A and the rate of change of its activity of R is defined as A is equals to minus dN by dt, that is decay rate, and R is equals to minus dA by dt, where Nt is the number of nuclei at the time T and 2 radioactive source P, mean life tau, and Q mean life 2 tau have the same activity at T equals to 0, and the rate of activity at T equals to 2 tau are Rp and Rq respectively. Then we have to find the ratio of this. Ratio is given to us, Rp divided by Rq, and this is equals to N divided by E. So we have to find the value of N here. So the solution of this question is, we have the activity of P is equals to A naught e power minus T divided by mean life, that is tau, and we have the activity of Q is equals to A naught, and this is e power T divided by 2 tau, and we have the rate of change of activity is equals to A naught divided by tau, and this is e power T divided by tau, and we have the rate of change of Q is equals to A naught divided by tau 2 tau, and this is e power T divided by 2 tau, that is our mean life here. So we have Rp, rate of change of activity Rp divided by Rq is equals to, we have to divide this. So if we divide 1 by 2, so we get the ratio here. So this is A naught divided by tau, and this is e power minus T divided by tau, that is the mean life, and this is A naught divided by 2 tau, and this is e power 2 tau. So this and this will cancel out, this and this will cancel out. So we left with, this is 2 divided by E, and we have given here this is N divided by E. So on comparing, we get N is equals to 2, and this is the answer for this question. Thank you. Hello students, today our question is, a freshly prepared sample of radioisotope of half-life 1386 second has activity 10 power 3 disintegration per second, and given that log 2 is 0.693 and the fraction of the initial number of nuclei that will be decay in the first 80 seconds after the preparation of the sample. So we have to find the initial nuclei, we have to find the fraction of the initial nuclei here. So the solution of this question is, we know that activity A, that is equals to decay rate, that is dN divided by dt, and this is lambda, and note that is the initial sample at time equals to 0, at time t is equals to 0, and this is e power lambda t. So from this we can say that at time equals to t is equals to 0, we have this value is 0, so we can say that lambda and naught is equals to 10 power 3. So this is 1 2 3 here, and we have given here half life is 1386 second. So from this we can find here lambda is equals to log 2 divided by t half life cycle, that is 5 multiplied by minus 4, and we have the NT, that is the radioactive sample at time t divided by initially radioactive sample at time t equals to 0, and node is equals to, this is the expansion of minus lambda t. So if we put the t is equals to 80 second, as we have to give the fraction at 80 seconds, so this is NT divided by N naught is equals to 0.96, and we can say that we can decayed amount is equals to 0.04, and this is 4% here, and this is the answer for this question. Thank you.
Hello students, our question is, the activity of a freshly prepared radioactive sample is 10 raised to the power 10 disintegrations per second, whose mean life is 10 raised to the power 9 seconds. The mass of an atom of the of this radioisotope is 10 raised to the power minus 25 kg. The mass in mg of the radioactive sample is. So solution for this will be, we know that activity A is given by disintegration dN by dt, okay, which is equals to minus alpha n. If we take the magnitude, so it will be equals to alpha n, and we can write alpha as, we know that tau is equals to 1 upon alpha. So from here A will be equals to 1 upon tau into n. Okay, so we have given the value of activity A. So 10 raised to the power 10 will be equals to 1 upon tau into n. So from here n will be equals to 10 raised to the power 10 into tau. So it is mean life is given 10 raised to the power 9. So 10 raised to the power 10 into 10 raised to the power 9, which means n is equals to 10 raised to the power 19. So we have to find the mass. So mass m will be equals to 10 raised to the power 19 into 10 raised to the power minus 25, which will be in kg. So it is equals to 10 raised to the power minus 6 kg. So we have to tell the answer in milligrams mg. So in mg, it will be equals to 10 raised to the power minus 6 into 10 raised to the power 3. So it will be equals to 10 raised to the power minus 3. It will be equals to 1 milligram. So the value of m will be equals to 1 milligram. And this is our answer. Thank you. Hello students, our question is, in the nuclear process, carbon 11 decays into beta 11 plus beta positive particle plus X, where X stands for. So we have to tell what X stands for. So solution for this will be, if we talk about beta positive decay, in this decay, mass number remains same, but atomic number decreases by 1. Okay, so this is beta decay. So in this decay, if carbon 611 decays into boron 11 5 plus, beta positive particle is represented by electron, which is having plus 1, plus a neutrino having 0 mass number and atomic number, because we have to balance both sides. Okay, atomic number and mass number, so it is already balanced. So the value which is X stands for is neutrino. So we can write X stands for neutrino. Okay.
Hello everyone. So we are given with a question which says, when a boron nucleus having mass number 10, atomic number as 5 is bombarded by a neutron, alpha particles are emitted. The resulting nucleus is of the element and has the mass number dash. So we need to find which element will be formed when the boron nucleus is bombarded by neutrons, and what will be its mass number. So let's begin. So we are given with a boron nucleus having mass number of 10, atomic number of 5, and when a neutron that is having a charge 0, that is no charge, so atomic number will be 0, and having a mass number of 1. So when this has been incident on a boron, so alpha particle is been emitted. Alpha particle is nothing but it is helium nucleus having a mass number of 4 and atomic number of 2. So what we are left with is this value is 10. So what we are left with is we are left with some new nuclei having a mass number of 7 and atomic number of 3. So as we can see, since a new element formed has atomic number as 3, so we can say it is a lithium nucleus. Alright, so we can say the element is lithium and it is having a mass number of 7. So here the answer will be Li and your mass number will be 7. Alright, so I hope you have understood the concept and thank you for watching.